Today we are gathered here to discuss the case study video which is related to the logic gates applications. The digital electronics subject, which is a core of our EC department, and it is adapted in second year to know about the core language, and it is very useful for the upcoming semesters. And this subject really helpful when we are preparing for placements also. As in additional kind subject, the first topic is logic gates. We know we have already some 12 standards and then we have studied logic gates. Today we will discuss the relevant example where we are using the logic gates in our processes in all our projects. Each we can discuss in detail.
Logic gates are the basic building block of digital electronic circuit. They perform logical operations on one or more binary input and produce a single binary output. The input and output of the logic gates are in the form of binary numbers 0 and 1. 0 represent false or true and 1 represent on or true. The mostly basic commonly used logic gates are and, or, and not. In additionally, other logic gates are NAND, NOR, XOR, and XOR.
NAND and NOR gates are called as universal gate. Why is it called as a universal gate?
Because we can implement all the basic gates using the universal gates. We have some set of rules to perform an input and output of the logic gate. Like that is truth table. Truth table shows the output determined by the input. We use logic gates in computers, calculators, and mobile phones and other electronic devices.
So, when deep diving into these logic gates, we are going to these components. So, as per the older revolution, we have seen a computer in a bigger room size. So, to make it smaller, we use the concept which is called PLSA. It is a upgraded one. PLSA is upgraded one. So, in starting, it is in as an SSI, MSI, LSI, and VLSI, and it going to be one intra scale integration. So, for a basic small stone for these concepts is logic gates. So, the first two gates I am going to explain about this AND gate and NOR gate. AND gate is a very basic gate which should know as the ma'am said in 10th standard or 12th standard. We had studied more about it in computer science also, in the physics subject also. Okay, so anybody know about De Morgan's law? So De Morgan's law is nothing but playing with these AND or NOT gates. Okay, in these AND gate we will use the operation of addition while giving both if 0 0 means the output also is 0. If 1 0 if we give means the output is 1. So if a statement 1 is false and other is true, we will get the output as true. If both are false, output is false, and both are true, the output is true. So this is the operation we will do in AND gate. Mostly AND gate we will use in mux and demuxes also, and in many other applications like flip flops, etc. So in OR gate we will use the operation of multiplication. In these multiplication steps, we will multiply if output is 1 and sorry if an input is 1 and output another input is 0, what will the output will get? 0. So this is the process of OR gate. So the basic two gates, that is AND gate and NOR gate, which will be used commonly in many applications. In applications, we will use these indicated OR gate on the flip flops and in other latches or in the okay, it is a great concept where in VLSI to design a gate in digital concept we will use these LGDs. About NOT gate and
NOT gate, which is inversion. If the input is false, the output will be true. The input is true, the output is false. It just gives the opposite of the what we are giving as input. It is called as NOT, which is called as inverter.
it acts also on the client. It's actually inverter.
And its applications are based on signal inverter, and it is used in automation.
like fans and automatic fans. If a person is still fan will be running. The person is not there, the fan will be automatically off. It means that if the input is zero, the output is true. If the input is one, the output will be.
So we can see the evolution of rising of electronics in these samples. So about the universal gate.
Yeah, one more. I'm going to explain about the XR, which is also used in the comparative.
Comparators.
Parity checkers, parity generators, and it is also used in toggles. And its operation will be if it has two inputs, A and B. If any one of the input will be different, I mean the A will be 0, B is 1, then the output will be 1. If the input is same, A and B is same, the output will be 0. Yeah.
So we discussed about the basic gates, that is AND, OR, and NOT, and so. So by coming into universal gates, we will use a vast number of electronic appliances in these universal gates. So about the universal gate.
I speak about land and knowledge. Land is nothing but usually about knowledge. First of all, land and knowledge to implement all other gates. It's a branch or it is in other often gates. It is in tree. It is a root and there is a tree. Other gates are tree. But first of all, NAND gate. And NAND gate is used in many other areas, especially in railways. In railways, NAND is used in railways. First of all, relays electron switch is actually switch. First of all, gate is used to convert switch or anything. Is used in fans or any switches. This gate is logic is very important to convert gates or any other any industries near there. And next, non-gate. The non-gate is nothing but it is English into an orchid. Both are same, but some of the difference in gates. Non-gate is used in many other processors or circuits. This gate is very important gate. Why we are using it is a monitoring gate or any other inputs we will give, it will respond to particular inputs. And this two gates are used to implement one of the gates and it will use in CPU or any other monitors.
Adding some points that is also used in security systems also. The small to a major. So why it is called as a universal gate is we can add another gate by combining this NAND gate and another gate. We will get out of the AND gate. As everybody knows. So there is a good case study on this gates.
Let's now discuss about the case study related to the basic logic gates and universal logic gates, and discuss the real game implications related to logic gates.
Thank you.